what's new in science. Today we will try to learn about green or renewable energy in detail. In part 1 we will talk about solar energy and other sources of renewable energy in the next part. First of all, we will discuss what green energy is and what are its main sources. Green energy is the type of energy that comes from natural or renewable sources. The sources that do not harm the environment and can be replenished naturally over time. Main sources of green energy. Solar energy from sunlight, using solar panels. Wind energy from moving air, using wind turbines. Hydropower energy from flowing water, like rivers or dams. Geothermal energy from heat inside the earth. Biomass energy from organic materials like plants and waste. 1. Solar energy. Solar energy is radiant energy from the sun's light and heat that can be harnessed to generate electricity or produce heat. This is primarily done through two main technologies. 1. Photovoltaics and 2. Solar thermal systems. Solar energy technology. How it works. Photovoltaics solar cells, typically made of silicon, capture photons from sunlight, which releases electrons from atoms and creates an electric current. Multiple cells are combined to form solar panels, which can be used to power homes, charge batteries, or feed electricity into the grid. Solar thermal. This method uses collectors and mirrors to focus solar heat onto a fluid. The heated fluid can then be used for space heating or hot water, or it can produce steam to drive a turbine and generate electricity. Key applications of solar energy. Electricity generation, converting sunlight directly into electricity for homes, businesses, and large-scale power grids. Water and space heating, using solar thermal systems to heat water for domestic use and swimming pools and to heat or cool buildings. Water pumping, providing power for pumps used in agriculture, for irrigation or for providing drinking water, especially in rural areas. Solar cooking, using solar cookers with reflective surfaces to cook food. Solar lighting, powering lights and lighting systems, from individual solar lanterns to street lights. Drying, using solar energy to dry agricultural products and other materials. Distillation, desalinating seawater to produce potable water. Vehicles, providing power for electric vehicles, such as solar-assisted cars. Sub-technologies. Solar water heaters, simple systems that use sunlight to heat water. Concentrated solar power, CSP, uses mirrors to concentrate sunlight onto a receiver to create high temperatures. The heat is used to generate steam to drive a turbine and produce electricity. Passive solar. Function integrates building design, orientation, and materials to naturally heat, cool, and light buildings without active mechanical systems. Energy storage. The function stores excess solar energy in batteries for use when the sun isn't shining, ensuring a consistent power supply. Importance, critical for grid-connected systems and off-grid applications. Advanced photovoltaic technologies. Function, improve the efficiency and durability of solar panels. Advantages of solar energy. Renewable and clean solar energy is an inexhaustible resource that produces no greenhouse gas emissions during operation. Versatile, it can be used for a wide range of applications, from small-scale residential power to large utility-scale power plants. Minimal maintenance. Once installed, solar photovoltaic systems have low maintenance requirements. Increases property value. Homes with solar panel systems may have a higher resale value. Potential drawbacks. Land use. Large-scale solar farms can require a significant amount of land. Intermittency energy production depends on sunlight, so energy storage or backup power sources are needed for nighttime or cloudy days. Efficiency. While improving, the efficiency of solar panels means not all sunlight is converted into electricity. Global solar power generation every year. World solar power generation is growing rapidly, with China leading in both capacity and generation. In 2024, global solar power installations reached a record-breaking 597 gigawatts, and China alone installed more solar capacity than the total capacity of most other countries combined. As of 2022, China and the United States together produced about half of the world's solar electricity, and this trend continues. Key statistics and trends of the year 2024 to 2025. Installed capacity. The total global solar capacity reached 2.2 terawatts in 2024, nearly doubling in just 2 years from 1 terawatt in 2022. Annual additions. A record 597 gigawatts of solar photovoltaics were added in 2024, a 33% increase over 2023. Solar accounted for 81% of all new renewable energy capacity added globally. Electricity generation share. Solar photovoltaics share of total global electricity generation rose to approximately 7% in 2024. Fastest growing source. Solar photovoltaics has consistently been the fastest growing power generation technology and is expected to become the largest renewable source, surpassing wind and hydropower, by 2029. Projections for 2025. Global photovoltaic installations are expected to grow by 10% in 2025, reach around 655 gigawatts, though growth rates may slow slightly due to market adjustments and potential policy changes in key markets. 2030 outlook. Cumulative solar capacity is projected to exceed 7 terawatts by 2030, playing a primary role in meeting the COP28 goal of tripling global renewable energy capacity. Leading markets. China remains the undisputed global leader in solar energy. In 2024, China installed 329 gigawatts, accounting for 55% of global additions. Other major markets include United States added a record 50 gigawatts in 2024. India experienced a significant rebound, adding 30.7 gigawatts in 2024. European Union added 62.6 gigawatts in 2024, with Germany being a significant drivers of growth in solar energy. Cost reductions. The cost of electricity from utility-scale solar photovoltaics has dropped dramatically in recent decades, making it the least costly option for new electricity generation in many parts of the world. Technological advancements. Innovations such as more efficient solar cells, for example, TOPCon technology, are continuously improving performance. Supportive policies. Government policies, such as the Inflation Reduction Act in the US and the Prime Minister Surya Ghar scheme in India, have been crucial in accelerating deployment.